Okay, here's our first problem now. We're going to take and try to find the area underneath this curve above the x-axis, and we're going to try to approximate it. That's our first start, is to approximate things. And there are two ways to do that. We have what we call lower sums and upper sums. Depending on the shape of the curve, the concavity of the curve, you may have one or the other or both in your calculation. Now, we're going to focus on a lower sum first of all. So what that means is that if this is your graph, well, I better get in here, get that thickness. Okay, here's your graph. It's the 2x plus 1, so it comes through something like this. And what we're going to do is create, okay, let's make sure we're, yeah, from 0 to 2. And okay, and we're doing this one on the lower sum. Okay, 4, n equals 4. So 0 to 2, 1, 2, 3, 4. So you can see I have 4 rectangles, and if I want a lower sum, I put them underneath like this. So we say that these rectangles are inscribed rectangles. They are under the curve. If when I'm going to do an upper sum, I would have my rectangles 1, 2, 3, 4. I would have them like this. This here we say that the rectangles circumscribe the curve itself. So here we've got the lower sum, and we call it a lower sum because we can see that our sum will be short. We're going to have missing area up in here, so we'll be missing this area here, 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 and here. Little pieces of area that won't be included. So we know that ahead of time. That's what's going to happen. We expect that to happen. Okay, so now each width in here of these rectangles are all the same. So the width, we tend to call the width delta x, and it is, in general, it's b minus a over n. So for us, that's 2 minus 0. I don't know why that happened. Sorry about that. Just kind of jumped on me. Okay, there we go. Okay, b minus a over n, which gives us, in this case, 2 minus 0 over 4. So it's equal to 1/2. And you can see each one of those is half wide. Okay, that's the width of each rectangle. Okay, now the height of each rectangle, we're going to, because we want the lower sum, we'll be taking our heights off of the left side of each of these rectangles. Okay, so to get that, we have to take, for the first height, for the first rectangle, we'll have over here, I'm going to list this, we'll have f of 0. For the second rectangle in here, we'll have f of 1/2. For the third rectangle, it will be f of 1. For the fourth rectangle, we'll have f of 3/2. Okay, so we have 1, 2, 3, and so now we have our numbers, and if we want the lower sum, now we just take and we put together the product of the width of the rectangle and the height of each rectangle. So without using any formal summation, what we have here is, for our first rectangle, we have 1/2 times the height f of 0 plus 1/2 times f of 1/2 plus 1/2 times f, f of 3/2 and plus 1/2 of times f of, let's see, 1, 2, 3, I missed one. Oops, I missed the 1 in there, f of 1, okay. They increment by half. Yeah, half here, there should have been 1 right here. So I got all these in here now. Notice this is a half times these different numbers. F of 0, remember f of x equals it. What was it? 2x squared plus 1, right? That's what f of x was. Let's make sure of that. Yeah, 2x squared plus 1. Okay. So now it's just a matter of getting these numbers in here. And you can see how this could easily be done on a calculator. If you remember what we did on that last example, we can get a calculator to do some of this for us. F of 0, that's 2 times 0 squared plus 1 plus f of a half, which is 2 times a half squared plus 1 plus 2 times 3/2 squared plus 1 plus 2 times 1 squared plus a 1. Okay, all of that. Okay, so let's continue in here. We've got, we can make this simple. We got 1, 1, 1, and 1. That makes 4. Okay, take care of these. Might as well get those out of the way. And then we've got 0 here. Here we've got 2 times 4th is a half. And then here we've got 2 times 9/4, which is 9/2. And then that takes care of that. And then finally over here, this last time we have just 2 times 1, which is a 2. Okay, so looks like we'll have 4 and 2 is 6, and this is 9 and 1 is 10 over 2 is 5. So that's 11 over 2, which is 5.5. Okay, so we got the sum there, and that is an approximation to the area. It's we can call the lower sum, in this case, using rectangles. And each rectangle has the same width. We call that a regular partition. What we just made here is a regular partition. And we partitioned the interval from 0 to 2 into equal subintervals. Each had a width of 1/2. That's called a regular partition. And here we got 5.5. Okay, now